Hello, this is Mr. Carlin. Let's talk about Lesson 10-4, Interquartile Range and Box Plots. Alright, Can's statement says, I can understand how a measure of variation describes the variability of data set with a single value, display, numerical data set in a box plot, and summarize the data. Alright, let's talk about learn measures of variation. Okay. Measures of variation are values that describe the variability or spread of the data. That is a vocab term, so make sure you have your highlighter and you highlight it. They describe how the values of a data set will vary with a single number. That's how vary means to change. Okay. One measure of variation is the range, which is the difference between the greatest and the least values in a data set. Okay, so range is the difference between the greatest and least values in a data set. So let's look at this data shown here. We have all these numbers and they're listed in order from least to greatest. So the data values range from 0 to 8. So the range is 8 minus 0, or we say it as 8. The least value is 0, greatest value is 8. So we do 8 minus 0 to get its range. So that means all the numbers fit in between 0 and 8, or there's a distance of 8. Okay. Another measure of variation is called interquartile range. Okay. Before you can find this measure, you first need to understand and find the quartiles. Okay. Quartiles divide the data into 4 equal parts. Okay, quartile sounds like quarter, takes 4 quarters to $1. The first quartile, or Q1, okay, quartiles or Q1, first quartile, is the median of the data values less than the median. Okay, what that means, it's the middle of the lower half of data. Okay. So up here, first quartile is middle of lower half of data. Okay. The third quartile, or Q3, is the median of the data values greater than the median. Okay. So third quartile, median of the data values greater than the median. That is the middle of the upper half of data. And then the median, which is also known as Q2 or second quartile. Okay. So let's look at this set of data right here. Okay. We have the same numbers from 0 to 8. Our median, or quartile 2, is where the middle is, right in the middle. So if we find the middle of data, it's going to be between 3 and 4. Okay. So Q1, the lower half of data, to find the Q1, that is the lower half of data. So from 0 to 3, we want the middle of that lower half. So that is our Q1, or first quartile. Or we can call it lower quartile. Then we have our upper half, okay, from 4 to 8, and in between that, the middle of the upper half, that's our Q3, so that number is between 6 and 7, or 6.5. So the interquartile range is the distance between the first and third quartiles in the data set. Okay, in order to find the IQR, okay, that's kind of a big one to know, IQR, or interquartile range, we subtract the first quartile from the third quartile. Okay, so we take this number 6.5 and we minus it by 1.5 to get our quartile range, interquartile range of 5. The interquartile range represents the middle half, or middle 50% of the data. The lower IQR, the lower the IQR is the data set, the closer the middle half of the data is to the median. So that's the smaller that number is, okay, that means that your data is more smushed in together. Okay? So if your IQR is a bigger number, then that means your data is more spread out. But the smaller the IQR, the more the data is closer together, or that the numbers are closer together. Okay? So given this set of data, our IQR is 6.5 minus 1.5, or 5. Okay? Alright. So the interquartile range describes how close the data is to the center. Okay? How close the data is to the center. So lower number, less variation. Bigger number, more variation. Alright, get this out of the way. Alright, example 1. Find the range in the interquartile range. So this table shows the approximate maximum speeds in miles per hour of different animals. We're going to use the range and interquartile range to describe how the data will vary. Part A, we need to describe the variation of the data using the range. So the greatest speed in this data set is 70, so that's our greatest, and our lowest speed, which is a spider, is 1. So our range is going to be 70 minus 1, so we have a range of 69 miles per hour. The speeds of the animals are going to vary by 69 miles per hour. That's how we would describe it using the range. So what we're going to do is find the median. We're going to write the speeds in order from least to greatest. Okay, so our smallest is 1, the next is 8, then I think 25, and then what's next? 30, and then 50, and then 70. Okay, cheetah, really fast. Alright, so the median, which is the middle, we're going to find that. Okay, it's going to be in between the two middle numbers. So what I like to do when I'm finding median is take my fingers and start at the ends, cover up one at a time until I get to the middle. Notice I have two numbers in the middle, so that means that I'm going to have to find their mean or their average. So I'm going to do 25 plus 30 divided by 2. Okay? When I do that, I think it's 27 and a half. Okay? So right here is my median. 27 and a half. Okay? Now we need to find the first and third quartiles. First quartile, which is the median of the lower half of data. So this is our lower half of data. We need to find its middle, starting at the end. I got 1, 8, and 25. Cover up one at a time. So I have 8. 8 is my middle there. My third quartile, starting at the end, cover up. So my middle quartile, or third quartile, is 50. So we're going to do Q3, which is 50, minus Q1, which is 8. Subtract those, and we get 42. Okay, so the spread of the middle 50% of the data is 42. That's kind of a higher number, so this means that the middle half of the data values vary by 42 miles per hour, and there is a large spread of the data. Okay? Alright. I want you to do this check question. Pause your video, then come back and check your work. Okay, it says the average wind speeds of several cities in Pennsylvania are given in the table. Use the range and interquartile range to describe how the data vary. So first we need to describe the variation of the data using the range. So to find range, we're going to find the smallest number, which is 7.5, and the largest number, which is 11. So we're going to do 11 minus 7.5. So that would be 3.5, I think. Yep. So our data, how do we say that? It varies. The speed, or let's see, the wind speeds the wind speeds vary by what did we say? That was 3.5? 3.5. Wind speeds vary by 3.5 miles per hour. Now we're going to describe the variation of the data with the interquartile range. So to do that, we're going to put these in order from least to greatest. So our smallest was 7.5. And the next one, 7.6. Then the next one, 7.7. And if you need to cross them out, that kind of helps. Then 8.9. And then 9 even. And whoops. And then 9.5. And then 11. Okay, so first we need to find the median. Okay, cover up one at a time. So 11, that one, that one, that one. So our middle should be this. So we got 1, 2, 3, 1, 2, 3. So our median is that. Okay, and we need to find our Q1. So this is going to be Q1, and this is going to be Q3. Remember, middle of the lower half, middle of the upper half. Okay. So we're going to do 9.5 minus 7.6. I'm going to need a calculator for that. So 9.5 minus 7.6. So our data varies by 1 9/10. So we would say the spread of the middle 50% of the data is 1.9. That is the distance from here to here. We would say the spread of the middle 50% of data is 1.9. Okay? Alright, so now let's talk about how to construct box and whisker plots. Okay? We're going to use that data to make those box plots. Alright? So a box plot or box and whisker plot uses a number line to show the distribution of the data set by plotting the median, the quartiles, and the extreme values. Okay? That's definition. The extreme values or extremes are the greatest and least values in the data set. Okay? So I'm going to highlight that. Extremes are the greatest and least. Okay, that's the end of the box and whisker. Okay? Lowest number, highest number. The box is drawn around the two quartiles and the whiskers extend from each quartile to the extreme data values. Unless the extremes are very far apart from the rest of the data set. The median is marked with a vertical line and separates the box into two parts. So when we have a set of numbers like this set up here, we find our median, and that's where our dot with a line goes. We find our biggest number, which is where the end of this whisker is. We find our highest number or lowest number, which is the end of this whisker, and then our Q1 and Q2 is where our box goes around. Box plots separate data into 4 sections. These sections are visual representations of quartiles. Even though the parts may differ in length, each contains 25% of the data. That is important. Okay, each section of the box plot contains 25% of the data. So how many parts did it say there was? There's 4 sections. So if this is 25%, then that means this is 25%, this is 25%, This is 25%. So 25 plus 25 plus 25, add all that together, makes 100% of the data. Okay? So this is a section, this is a section, and this is a section. 1, 2, 3, 4 sections at 25% of the data. Sometimes they may not look visually like they have 25%, that one whisker may be longer than the other, and that tells us something about the data, but that means that 25% of the numbers are in that range. Okay? Alright. A longer box or whiskers indicate the data is more spread out in that section. That is important to know, and we'll see that here in a second. But if your box and whiskers are more spread or longer, then that means the data is more spread out. It means 25% of the data is stretched out. Okay? It does not mean that there's more data values in that section. It just means it's more spread out. Each section contains the same number of values, which is 25% of the data. Okay? All right. Example 2, we're going to interpret. So the box plot shows the annual snowfall totals in inches for a certain city over a period of 20 years. Okay? Now notice in this box plot, like each piece between is different lengths. Okay? We're going to describe the distribution of the data. What does it tell you about the snowfall in the city? So the annual snowfall ranges from about 110 inches, so from about 110 is here, to about 250, which is about here. So that is the range, is what it's telling us. Okay, so we can see what the range is. The middle half of the data ranges, that's this piece right here, ranges from about 140 to 195. So its range of the middle half of the data is here. Because the boxes are shorter than the whiskers, there is less variation among the middle half of the data. So what that means is that, notice we have a long whisker, kind of a longer whisker here. Okay, the whiskers together are a lot longer than the boxes itself. So that means that the data is more spread out. Okay, or the data out here is more spread out, but inside we have less variation. Okay, in the middle half of the data. So that means from here to here, our data is more smushed in, less variation. Having less variation means there is a greater consistency among the middle 50% of the data in either whisker. Okay? Alright, so let's look at this one. The average gas mileage in miles per gallon for various sedans is shown in the box plot. Describe the distribution of the data. What does it tell you about the average gas mile of those sedans? Okay, so when we're looking at this, what do you notice? Well, we notice our whisker over here is a lot longer, okay, than our box. Okay, so our boxes are more smushed in, especially in this lower quartile here. Okay, so to describe this, we would say that there is more consistency and less variation, okay, in the middle half of the data. That's how you would describe that. Less variation among the middle half of the data. Okay, less variation in the middle half of the data. Now we could get real wordy and explain what the range is and what the IQR is, okay, but I'm going to save time and move on from that. Alright, so let's talk about how to construct and interpret them. Box and whisker plots. So here we have a table that shows the recorded speeds of cars traveling on a county road. Notice it looks like they are not in order from least to greatest. Okay, so we're going to probably need them in order from least to greatest. So the first thing we do is, it says step 1, order the values from least to greatest. So we do that. Okay. Then we're going to graph the values above a number line. Okay. We're going to find the median and graph it, the extremes, the biggest and smallest numbers, and graph them, and the first and third quartiles and graph those values. Okay, so I always like to start with the upper, the biggest, which is 40, so we put a dot at 40. Our lowest, which is 19, so we put a dot at 19. Then we need to find the middle, so since they wish they would have put them in a line a little better for us. But it looks like when they do find the middle, they end up with 25 as the middle, so that's our median. So then our middle half, or middle of lower half, is going to end up being 22, and our middle of the upper half is going to end up being 34. So we put dots for those. Then we draw a box around the quartiles, around the upper and lower quartile, and then we draw our whiskers out to the extremes. Okay, so we would like put a box around our quartiles, a line through the median, and then draw our whiskers out to the extremes. Then to describe it, we would look at this, and it looks actually like the whiskers are shorter than the box, so we would say that there is less consistency among the middle 50% of the data, because the box is longer than the whiskers. Okay? Alright. So this just helps us to visualize how that data varies. Alright, I want you to do this check question by constructing a box and whisker plot and then describing the data. Pause your video, come back, and check your work. Alright, it says earthquakes occur at different depths below Earth's surface. Stronger earthquakes happen at depths that are closer to the surface. The table shows the depths of recent earthquakes in kilometers. Okay, so we're going to construct a box and whisker, but the first thing we have to do is put them in order from least to greatest. Okay, so our smallest is 1, so we're going to write them all down. 1, so I like to cross them out so I don't get confused and use it again on accident. And then 2, and then 3, and then we have a 4, and then a 5, 5, and 5. So we have 3 5s that we need to write down. Okay, so 5, 5, 5. And then, let's see, do we got any 6s? No. 7, 7. So there's 2 of those. And then no 8s, and then we got 2 9s. So put both of those 9s. And then a 10. And then 11 and 15. So our number line, when we draw our number line, is going to have to go from 1 to 15 at least. So let's put 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Alright, so we're going to have a lower and an upper extreme. So we're going to put dots at 15 and dots at 1. Now we need to find our median. Okay, so we cover up the ends and go one by one. So I have 5 and 7 in the middle. So what's between 5 and 7? 6. So that means our median is right here. And we say that our median is 6. So we put a dot at it. Now we find the middle of the lower half. Okay. Looks like it's going to be 4. Okay. And then the middle of the upper half. So it's 9. So we put our box around the middle of the upper and lower halves. Oop, nah, we don't need that line there. We need a line this way. Sorry. And then our whiskers. Well, the whiskers are really spread out. Okay. So our whiskers are more spread out, so that means that there is less variation in the middle half of the data. Okay? And there's more you could say there's more variation in this 25% of data. Okay? All right. I want you to do questions 1 through 5 on the next page. Check your work with your teacher. Thank you.